Welcome to Today Easy Grab Tutorials. Thank you for following our YouTube channels and liking our lectures. In today's lecture, we will look at a practical processing facility and identify some important process control and instruments commonly found in process line. As shown in this video is a typical processing facility or processing line. You can see instruments on it and several equipment on the line. But first, let's look at what industrial process control is. Industrial process control refers to systematic management of various parameters and regulation of process variables in the processing plant. Let me repeat that again. Industrial process control refers to systematic management of various parameters and regulation of process variables in the processing plant. So why do we need process control? Process control has helped industries to improve quality. They also help to increase production and efficiency. Process control also improve consistency. It helps reduce waste and save cost of production. There are two types of process control. We have open loop control and closed loop control. The difference between both is very simple. In open loop control, there's no feedback on the process output based on the real-time input condition. That is, in open loop control, there's no feedback from the field to the controller. But in closed loop control, there is feedback for continuous real-time adjustment to maintain desired output. That is, in closed loop control, it uses feedback to communicate to and from the remote area. It is worth noting that industrial process control leverage on instruments which are used to monitor, control, and automate different processes. So they make use of instruments for the continuous monitoring, control, and automation of different processes. These instruments are classified based on their functions in the process. One of the instrument classification is measuring instruments. Example of this measurement instrument, we have pressure transmitter / pressure gauges. We have flow transmitter, level transmitter / gauge, temperature transmitter / gauge. We also have another measuring instrument called analyzers, which is used to monitor the composition of fluid for quality control. We also have another classes of instrument called control instrument. Example of this control instrument, we have control valves, which regulate flow in the process line. We have actuator. These provide the mechanical force to open and close control valves. We also have positioner, which is used to control valves actuator based on signal from controllers. And we have the main brain of this automation and control, which is controllers. This is where the control algorithms are programmed to interpret data from measurement devices and send signals to the control instrument for action. That is what controller does. Example of this controller is PLC, DCS. We also have one of the commonly used control algorithm called PID control. The PID means proportional, integer, and derivatives, which helps to maintain process variables like temperature, flow, level, pressure at set point by adjusting control output according to deviations from the desired values. That is what the PID does. It can come on its own module, or can also be found in the PLC module itself. You know, when we mean PLC, we mean programmable logic controller. When we mean DCAs, we mean distributed control system. And SCADA/HMI, you know what SCADA does in automation. SCADA is used for supervisory monitoring, and HMI is configured to enhance human-machine interaction. The personnel monitor the process line using the HMI and impute or effect any change from the HMI, and that will be implemented on the field through the PLC configuration. So we also have another classes of instrument called safety instrument. This is very, very important in a safety critical environment, like in the oil and gas environment, where safety is very, very paramount because of the huge risks and hazard involved in such environment. Another industry that safety is highly paramount is chemical industry. One of the safety instruments is pressure relief valves or pressure safety valves. Another is gas detector. We also have flame/fire detector as one of the safety instruments. Let me also mention that blow down valves and shut down valves are part of safety instruments in a process facility. Note that whenever there is upset in the process line, or when parameters are beyond range, that is abnormal condition, there is likely to be an alarm. It is programmed to notify the operator of the abnormal condition in the process so that an action should be taken before issues arise. So we will move straightly to identification of this component in this process plant. Please follow us. We will move fast in order to catch up with our time. First, we have pressure gauge. Okay, this is the pressure gauge. This is used to measure the pressure in the process line. It is connected to the process line. As you can see, the process line, fluid or liquid or gas is passing through the line, and the pressure gauge is used to measure the pressure on the line. The pressure gauge will display the pressure in both bar or PSI. As this gauge is, you can see in bar or PSI. The bar is the black color from 0 to 60, and the PSI is in the red color 0 to 860 PSI. Depending on the unit usually used by your organization, you can convert from bar to PSI as the case may be. Some instruments or some gauge may display the figure in kPa, Pascal. So, but this one, to convert from bar to PSI, we use the normal formula: 1 bar equals to 14.5 PSI approximately. So remember the formula, it helps. Also on the process line is the pressure indicator transmitter. You can see on the screen there is pressure on the line just like it was displayed on the gauge. If you compare the pressure on the PIT pressure transmitter to that of the gauge, you will see they are almost the same. So the pressure indication transmitter measures the pressure on the line, display it, and transmit to remote area for monitoring and control purposes. Okay, that is what the pressure indicator transmitter does. We also have on the line temperature transmitter. This temperature transmitter measure the temperature of the fluid passing through the line. Okay, it has a probe. This is the probe that it uses to sense the signal. You know, there are many sensors that is used to sense temperature. One of the sensors, we have thermocouple, thermistor, we have RTD, among others. Okay, so this is the temperature transmitter, TIT, temperature indicator transmitter. It will measure the temperature, display the figure as you can see, and also transmit the same value measured to remote area for monitoring and control. Also on the line, we have flow indicator transmitter to measure the volumetric flow rate of the fluid passing through the line. As you can see, you can see the screen. It measure, display the value, and transmit the exact value to a remote area. If you can recall, that volumetric flow rate is the mass flow rate divided by density of the fluid, and you know density is affected by temperature, pressure, and composition of the fluid. Also in this process line is sight glass. We call this instrument sight glass. All these instruments explain now are measuring instruments. This is sight glass for level measurement. It is local gauge, so you can see the level physically on the field. It is calibrated glass. As you can see, it has calibration on the body. Okay, it is used to measure level in the vessel. As you see, it has 2 points connected to the vessel, so you can check the difference in levels. Also for level measurement is level indicator transmitter. As you can see, this level indicator transmitter, it is usually installed on a bridle. This is called bridle. As you see, it is installed on the bridle. The bridle is connected to the vessel at upper and lower points. This level indicator transmitter measure and indicate and transmit level of a substance within a container. That is what the level indicator transmitter does. As you can see, two are installed monitoring the level in the vessel. In addition to the sight glass, you know, you compare both the sight glass and the transmitter reading. So this level indicator transmitter works by measuring or converting the measured level into electrical signals. For this type of a transmitter, it uses radar technology to measure level. It emits radar pulse, and the time difference between the transmitted and reflected pulses is used to calculate the level. That is the basic operating principle of this level indicator transmitter. I said it uses radar technology to measure the level. It emits radar pulse, and the time difference between the transmitted and reflected pulses is used to calculate the level. Also, another important measuring equipment used in processing plants is pressure differential transmitter, or you put it in other words, differential pressure transmitter. This measuring equipment here is called differential pressure transmitter. You can see it has value, and you can see it has tubings connected to both high and low points in the vessel. So what this transmitter does is to measure the difference in pressure between 2 points in a system. It converts the pressure difference into electrical signals, mostly 4 to 20 milliamps. It is also used to measure pressure drop in the industrial process line. One thing good about this transmitter is its huge advantage. Some key features of this differential pressure transmitter are: 1. It is used for flow measurement. They can be used with devices like orifice plates or venturi tubes to measure flow rate in pipes. This differential pressure transmitter can be used for flow measurement. If it is used for flow measurement, it will be used in connection with orifice plates or venturi tubes to measure flow rate in pipes. It can also be used for level measurement. When it is used for level measurement, it determines the level of liquids in the vessel by measuring the hydrostatic pressure at the top and bottom of the vessel or tank. So when it is used for level measurement, it measures the hydrostatic pressure at the top and bottom of the vessel. Let me also mention that they can also be used to monitor pressure drop across filters. That is where you have differential pressure in the filter, to know if the filter is clogged or not. So when it is clogged, you see the pressure will increase. That the pressure across the filter will increase. In our subsequent video, we will go into detailed explanation of some of these important components in processing facility. Let us move to control equipment. Having explained most of the measuring instruments in the processing plant, we will go straight to control instruments. So one of the control instruments we mentioned earlier was control valves. This pressure control valve, as you can see, it has a regulator on the body. It also has a regulator, what we call air regulator, attached to the body. It also has an actuator. Remember when we mentioned control instrument, we mentioned actuator, control valves, positioner, and controllers. So this control valve, pressure control valve, these valves names are given based on the purpose in the line, the process line. Like this, its purpose is to regulate pressure in the system using signals from the pressure transmitter. What this means is that the pressure transmitter will measure the pressure on the line, send the information to the controller, and the controller in return will take action on how the valve should operate and at what level should the valve open or close. Another control instrument is level control valve. As you can see, this level control valve is very similar to the pressure control valve. The difference is the function it is performing in that process line. In this process line, its duty is to measure, to regulate the level in the line. It's regulate the level in the vessel or flowing through the line using the level transmitter information. So the level transmitter will send the level information to the PLC or the controller, which will in turn regulate the valve opening or closing. Another control instrument is colorimeter. Colorimeter is measuring instrument used to measure mass flow rate in the line. It operates using the principle of motion mechanics or Colori's effect, where inertia due to fluid flow affect the vibration of tubes within the meter. This creates a twisting force on the tubes, which is then measured by sensor. It has some parts. One of the parts is flow tubes. This flow tube, it also has sensor and the transmitter. You see the line connecting the transmitter to the sensor that is installed on the flow tube. Also in the process line, we have flow control valve. These flow control valves help to regulate the fluid flow in the line. All these control valves uses air for its opening and closing action. These flow control valves uses signal from the flow transmitter, which measures the flow rate, send the information to the controller. The controller in turn will regulate the flow valve's opening and at what percent it should open for the fluid to pass. The last classes of instrument we will discuss in this lecture will be safety instruments. As you can see, this is one of the safety instruments we mentioned, flame detector, to detect the presence of flame and possibility of fire outbreak in the process line. That is flame detector. You can see it's active, that is why it's blinking the light. Another safety instrument is gas detector. You can see it's active, that is why it's blinking the light, detecting the presence of toxic or flammable gases that are harmful to human. Another type of safety instrument or safety equipment is blow down valve. Remember when we mentioned the safety instrument or equipment, we mentioned the blow down valves and the shut down valves. These blow down valves are used to depressurize system or vessel by releasing pressure through flare or vent, mostly on emergency. So during emergency, this blow down valve will act automatically to depressurize the system or vessel and release this pressure to the flare line or to the vent line, therefore protecting the system from damage. Another safety critical equipment in the processing plant is the shutdown valve. The shutdown valves are used to shut off fluid and isolate systems during plant or emergency situation. So what this shutdown valve does is to isolate or shut down the fluid flow and isolate the system. During emergency, it isolates the system. At times, in case of maybe plant shutdown, it is used to isolate the system. Also, one of the safety critical equipment in the processing facility is pressure safety valve. Pressure safety valve. This pressure safety valve is a type of valve used to quickly release gases from equipment in order to avoid overpressurization and potential process safety incidents. So this pressure safety valve will pop open as soon as the pressure in the line is higher than the set value. It pop open and release the pressure immediately to keep the line at minimum pressure. Also, it's similar to the operation of pressure relief valves, which release stored gas in various equipment. So I said that pressure relief valves is also a safety critical valve used to release stored gas in various equipment to maintain an optimal pressure level. Both these pressure safety valve and pressure relief valves are referred to as pressure relieving devices. These valves are automatically operated using air for its actuation. This way we will end our class today. We have tried our best to mention and identify some of these measuring instrument, control instrument, and safety instruments or equipment in the processing plant. In our subsequent video, we will try to make deeper explanation on some of these equipment. Thank you for watching our videos. Keep on visiting our YouTube channels for more impactful tutorial on process plants, electrical machines, and power system. I am Engineer Ndifreke Owa. Thank you.